Welcome to Lesson 4E, Heat Stress, Part 1.
This is the first part of a two-part series on thermal comfort and heat stress. We're going to talk a little bit today about body metabolism. First, wanted to mention a couple introductory things. Human beings are what we call homeotherms. Therm meaning temperature, homo meaning same. So homeotherms are creatures like us who maintain a constant temperature. This is our internal or core body temperature, which everyone knows is 98.6 degrees F or 37.0 degrees C. Our bodies do everything they can to try to maintain that constant temperature. We get into heat stress, and that could be either too cold or too hot. We also have thermal comfort problems when we're too cold or too hot. There's two extremes. If we cannot maintain our temperature and our body starts changing temperature, our core temperature starts rising or falling. Hypothermia is a case where it's too cold, and we define that as T, this internal core body temperature drops below about 96 degrees F. So if you're stuck in a really cold environment for a long time, your body core temperature starts to drop, and you have a condition called hypothermia when it drops below about 96. This accounts for approximately 1,500 deaths per year. The opposite is hyperthermia, and that's when it's too hot. Body core temperature gets above about 105 degrees F. So you have a fever, and if you get above about 105, you're really in trouble, and this causes about 600 deaths per year. More people die from the cold than from the heat in a given year. Particularly susceptible are infants, elderly, and infirmed, in other words, sick people. And how do you remember the difference between hypo and hyper? Hyper means too much. So I remember it because I had a son who was hyperactive, in other words, too active. Some of you may have been that way. So hyper means too much. Hypo, that little O there looks like a zero, so it tends to remind me that it's something small. So hypo means too low or too little. Elderly are particularly vulnerable. Here's an article from 2017. After Hurricane Irma had swept through in Florida, they lost air conditioning. Elderly people in a nursing home started getting too hot, and unfortunately 8 people died. On the opposite extreme, hypothermia, too cold, January of 2020, a 16-year-old girl died from hypothermia. These are situations that can occur both inside and outside. Let's look at metabolism and metabolic rate. How does the body maintain its heat? How does it maintain its temperature? Well, there's chemical reactions. Our cells burn food with oxygen that's taken to the cells by the blood through hemoglobin. We talked about all that previously. And then they turn it into CO2 plus heat, energy in the heat. That's what keeps us warm.
But, sir, where does the carbon come from to make the CO2?
Good question, Boris. The carbon comes from the food we eat.
That makes sense. Thank you, sir.
We'll let m dot be the metabolic rate. The dimensions of m dot, this is a capital M, so it's not a mass flow rate, it's a metabolic rate, are the dimensions of power, energy per time. The units of m dot can be watts, capital W, or kilocalories per hour, or kilocalories per day, or whatever other unit you want to put in the bottom. Note that a kilocalorie is the same thing as what some people use a capital C as a calorie. That's a kilocalorie, which is 1,000 little c lowercase calories. This calorie is the thermodynamics unit, but when people talk about food, it's this calorie. And if you look at labels, a lot of them have C in capitals, some don't. But when you're looking at food labels, these are always in kilocalorie or capital C calorie. For example, a Snickers bar, 250 calories. That is a capital C calories, or 250 kilocalories, or 250,000 little c calories. The conversion from watts to kilocalories per hour is 1 watt is equal to 0.86 kilocalories per hour. So these units are pretty similar. They're almost the same, just 86%. So if you're talking about 100 watts, that's going to be 86 kilocalories per hour. We're going to also have another notation here. Let m dot B equal BMR. That's called the basal. Basal just means base metabolic rate. So this is for a person lying down at least 30 minutes, but not asleep. When you're sleeping, the metabolic rate is even lower than that. The actual MDOT varies with your activity level or exercise. So obviously MDOT goes up with activity. In the book, table 3.6, we have the metabolic rate as a function of physical activity for an average adult man. The basal metabolic rate in kilocalories per hour is 72.2, watts is 84. Notice that sleeping is a little lower than that, only about 62 kilocalories per hour. And if you're seated, quiet, like most of you are just watching this lecture, you're burning almost 100 kilocalories per hour. Now this varies greatly depending on your weight, your height, whether you're a male or female, etc. So let's describe first the average man. What are the average man's attributes? He has a mass of 70 kilograms. You can convert that to about 154 pound mass. He's 18 years old, so a young man. He's healthy. He is 5 feet 10 and a half inches in height, which is 179 centimeters. He's the ideal weight. In other words, he's not too fat, he's not too skinny. So this is what they call an average man. This table is for this average man with a basal metabolic rate of 72.2 kilocalories per hour. And notice that sleeping is less than BMR. As you go up in activity, house cleaning, 244 kilocalories per hour. Playing basketball, it's a lot higher. Heavy exercise, this is like really swimming hard or running. You can get up to more than a factor of 10 above your basal metabolic rate. The average man, we'll call this M.B or BMR. I'll use both of those notations for this. His basal metabolic rate, as in red there, is 84 watts or 72.2 kilocalories per hour. Quick example, suppose this average man does these activities throughout the day. He sleeps 8 hours. He watches TV for 15 hours. He's a couch potato. And he walks around to go get some food and to go to the bathroom. But other than that, he sits and watches TV. So let's suppose he walks for 1 hour. So how many kilocalories per day does this couch potato average man burn? Well, we can calculate the total capital C calories as the time, 8 hours, times that activity sleeping. So it's 62 kilocalorie per hour. He spends 15 hours watching TV. So that's seated and quiet. So that's 93 kilocalories per hour. And he has 1 hour of walking around, walking about the office. Let's call that 155 kilocalories per hour. You get 2046 kilocalories in 1 day. Now, generally speaking, and there's a lot of unknowns about how we gain weight and how we store fat, but if he eats more than 2,000 kilocalories per day, he's not going to remain an average man. He's going to gain a lot of weight, so he will get fatter. He needs about 2,000 kilocalories to maintain his weight. If he doesn't eat enough, he'll start losing weight. What about other people that are not average? Well, I'm going to give you 2 methods. The first one I don't want you to use, but use sometimes just for a quick and dirty approximation. I just want to show you the easy way of doing this. And let's take me as an example. I weigh 175 pound mass. The average man is a 154 pound mass. That extra 21 pound difference here, by the way, is solid muscle.
I have an extra 40 pounds of solid muscle.
Thanks, Arnold, but that may be a little TMI. So a quick and dirty approximation is to say BMR of me is equal to BMR of the average man. And all I'm going to do is take a ratio of the mass. So the mass of me over the mass of the average man. I'm going to start abbreviating this AM, average man. So that's just a quick and dirty approximation. So we plug in the numbers. We get 72.2, this is kilocalories per hour, times my mass, 175 pound mass over the average man's mass, 154 pound mass. I don't care if they're English units because they cancel out. This gives me 82.0 kilocalorie per hour. Now, the reason that this is not correct is that I'm not 18. I'm not 5 feet 10 and a half inches tall. I'm healthy. I'm probably not at my ideal weight, a little bit chubby. So this is just an estimate. And again, let's not use that. But there's a better way, and this applies to both males and females. This is the preferred way. All homework, all quizzes, all exams, final exam, whatever. Always use this, the Mifflin St. Jeor equation. I'm going to abbreviate that MSJ equation. And this calculates the basal metabolic rate based on 4 things: gender, either M or F. There's only 2 genders in this MSJ equation: body mass, body height, and body age. And there's some restrictions. It applies to healthy people. If you have certain diseases, it could affect your BMR, so this would not apply. And it also applies to over age 18. M.B or BMR is 10 times your mass in kilogram over kilogram plus 6.25, height in centimeters minus 5 age over 1 year. And then there's this other part that's either 5 for a male or negative 161 for a female. Females have a smaller metabolic rate than males. So that's the equation. And it's a so-called engineering equation, which means the mass has to be in kilograms, height has to be in centimeters, etc. So let's use me again. Mass, as I said, is 175 pound mass. My height is 5 feet 7 inches. My age is 63 years, and I'm a male, so this would be plus 5. So let's calculate BMR using this MSJ equation. 10 times 175 pound mass. The reason there's a 1 kilogram in the bottom is to make sure that you do your units correctly. So you need a unity conversion factor. A kilogram is 2.2046 pound mass plus 6.25 times 5 feet plus 7/12 feet over 1 centimeter. So I need to convert again, 30.48 centimeters per foot minus 5.0 times 63 years over 1 year. And then this 5 or negative 161 for S is already non-dimensional. So everything is non-dimensional. All these units cancel out everywhere. And the answer is in kilocalorie per day. When I plug in the numbers, BMR equals 1547.4 kilocalories per day. 1 day is 24 hours. So this is 64.48. You're not any better than 3 significant digits, certainly with these. Probably only 2, but keep about 3 just for consistency. Kilocalories per hour. So this is BMR for me, yours truly. Compare that to my quick and dirty calculation, which was 82, not very close. I want to quickly show you this nifty calculator for BMR that you can use for homework and stuff, but I would actually advise you not to, just maybe to check your answer. I'd advise you when you're doing this homework to write this equation out in whatever program you're using. If you're doing this on the computer, which I strongly encourage for all your cases to make sure you don't have math errors, you can put that equation in and then check it with this website, this BMR calculator, basal metabolic rate, Mifflin St. Jeor equation. Click on that. Let's do me. So I'm a male. My age is 63. My height, you can change the units to centimeters if you know that instead. 5 feet 7 inches. And my weight, 175. And the result is 1547. And that's exactly what I got here. Suppose there was a female who was exactly the same as me, 63 years, 5 foot 7, 175 pounds. All we want to do is change this to a female. Notice it dropped to 1381. So sorry, ladies, you burn a lot less calories than a man your exact same height and weight and age does. This also decreases with age. So if she was the same person at 18, it goes up quite a bit. You burn less calories with age. And that's why your grandfather doesn't eat as much as you do. How to estimate metabolic rate for various activity levels. Here's the procedure. This is what I want you to do, is to use table 3.6 to get two things, the m dot at exercise and m dot b, the basal rate for the average man, or AM I'll abbreviate. And then we're going to use this MSJ equation to get the basal metabolic rate actual. And then we're going to scale linearly to estimate m dot actual at that same activity level. So we're going to assume that the rate at which these things go up with exercise is going to remain the same linearly with the ratio of the actual m dot to the m dot of the average man. So I'm going to do it by example. It's easiest to learn with example. Jenny's 22 years old. She weighs 130 pounds. 5 feet 5 inches tall. She's doing some rigorous calisthenic exercise. How many kilocalories does Jenny burn in 30 minutes of this exercise? Here's the table repeated. I need a couple things from here. I need this value for basal metabolic rate for the average man, and then you have to look for this calisthenics exercise is this row, so that's 317 kilocalories per hour. So now we can do the calculations. We first write down m dot b, basal metabolic rate for the average man. This is always going to be the same, 72.2 kilocalories per hour. And m dot average man with exercise is this value from the table, 317 kilocalorie per hour. And then let's use the MSJ equation. I get 1350.6 kilocalorie per day. 1 day is 24 hours, so this becomes 56.28 kilocalorie per hour. Here's the equation that I will use for our best estimate, assuming linear. So I'm doing these three steps, 1, 2, 3. I did 1, I did 2, and now 3 is our best estimate. In terms of an equation, I'm going to write m dot actual for this person is equal to m dot AM, the metabolic rate of the average man, times m dot B actual, basal metabolic rate actual, that's what we just calculated. So we're going to call this m dot B actual. And then we just divide by m dot B average man. So this is the equation that you want to use for these kind of problems. And when we plug in the numbers, we get 317 kilocalories per hour, 56.28 kilocalories per hour, divided by 72.2 kilocalories per hour. You see that the units here and the units here cancel, and so we get 247.1 kilocalories per hour. And the question asked, how many calories does Jenny burn in 30 minutes, which is a half of an hour, so it would be half of this value. So she burns half of that, or 123 kilocalorie in 1/2 hour. That may surprise you. Doing calisthenics for a half hour, you're going to get pretty tired and sweaty. This is about half of a bag of M&Ms. It's kind of surprising how small that is, but compared to BMR, the same person at BMR would burn only 31 kilocalories in a half hour. So exercising helps, but it's not a lot of calories compared to 2,000 a day or so. So the bottom line is you need to exercise a lot to burn calories. Sorry, Jenny, you need to really work out hard to lose some of that weight.
Thank you for watching this video. Please subscribe to my YouTube channel for more videos. 1, 2, 3.